let's start because we have a lot to see. So I will start with some presentation. So my name is Frédéric Descamps. I am known as Lefret in the MySQL community. So on Twitter, you can find me if you have any question or whatever. So you can find me on @Lefret. So I am MySQL evangelist here in Oracle, and I'm using MySQL since a lot of time. So since version 3.21. I'm also a DevOps believer, and I'm living in Belgium. And as you can see, I'm born at PiDay, and I have a blog called lefret.be that gives you a lot of information related to MySQL. And because I'm not lying, I want to show you that I'm really born on PiDay. So today is my birthday. So let's start with IoT, the Internet of Things. What is it? So the Internet of Things describes a network of all physical objects, like this one, a small Raspberry Pi. So things that are embedded with sensors and software on it, and that let's say gather a lot of data. It has a lot of purpose, of course, and it generates a lot of data. This is what we're going to play with today. And so this device is arranged very from ordinary old objects to some very sophisticated industrial tools and a lot of stuff like that. So currently, we estimate about 7 billion connected IoT devices today, and the experts are expecting even more, a bigger growth to 22 billion by 2025. So it's a lot of data that we need to process, and we're going to see together how we can process that data. Of course, you may know MySQL. So MySQL is the most popular open source database in the world. So a relational database, but not only, and we're going to see that also together. And so I will start talking about MySQL and how we're going to store all this data that we collect in MySQL. Also, if you have followed Oracle and the news, you know that there is also MySQL HeatWave now. So MySQL is the most open source database, and it's developed by Oracle. But also this database, which is relational, so RDBMS, it's also can be also used as a NoSQL document store. And now it is also available in Oracle Cloud Infrastructure, so OCI, and as a managed service, so you don't have to do anything. So all is managed by the MySQL team in OCI, and it has an edition called HeatWave. So HeatWave, it's a massively high performance in-memory query accelerator for OCI, and it gives you very good performance for analytics, but not only. And we're going to see that for also a mixed workload. So this is MySQL. We're going to see in details more about that in a few slides, but this is the base where we're going to store our data during this session. Then we have a Raspberry Pi. So it has the hardware and the software for one of these IoT object or IoT device. For the session, I use a very old one, which is a Raspberry Pi Model B. If I check, it was made 2011, right? And but it's enough for what I want to show you today. So what I want to demonstrate, and I'm using a Dht22 sensor, very cheap sensor that provides to measure the temperature and the humidity, which is just to gather and generate a lot of data. So this is very easy to deploy and to use, and you don't need to be a big engineer to create this, because the assembly is very easy. So you have two cables that needs to go to the to the ground and the 3 volt for the power, and then one sends the data on GPIO 4. That's it. Then on this Raspberry Pi, where we have Linux installed on it, we need to have other packages that we're going to use today. So I will use Python. I will use also pip, MySQL connector Python. So we're going to see also after that MySQL has a lot of connectors, And in this case, we're going to use the MySQL connector Python. So when you see MySQL connector Python, MySQL connector Java, this means that these connectors are maintained and delivered by the MySQL team itself, right? And I use another module called Adafruit Python DHT to read the data that comes from that sensor, right? And of course, we're going to also need to create some software ourselves, so our own program to manage that. One, to start, stop, and get the status of the program we're going to create. So I will use systemd, and the name it's PiDay metrics here at .service. And we have also the software itself that will collect the data and send it to MySQL, which is called metrics to mysql.py. All the source of the code, for example, for these examples, are also on GitHub, and you will have the link at the end of the slides and during the session. So this is the software that we're going to install on our device, and or that we're going to write ourselves. And we're going to see after how to write and what to write. And so this will be what's in the sensor in this device, but this device will also send data somewhere. And that data will be sent, in our case, in OCI, so in Oracle Cloud Infrastructure. So this is the architecture that we're going to use. So we have on the internet devices that you can see here, and they will connect on OCI using the internet gateway to a compute instance where we have MySQL router installed. So MySQL router will retrieve all the data and send it to MySQL Database Service. Because if you have already used MySQL Database Service, you don't have a public IP for security reason. You need to use VPNs or MySQL router or other solutions to connect to. So here we have a router. This is a very simplified architecture. We can do more, and I will show you that also later to have something even more professional, right? But to start, this is how we're gonna do. So, and as you saw with HeatWave, we can perform real-time analytics without having to use ETL. So this is also something very important, because when we collect all that data, so we collect data, a large number of data. You will see that this can be in 2025 like 20 billions of devices sending data. So that data will be sent to MySQL. You may know that MySQL, it's very good to process all these transactions, but it's not always the fastest with analytics, of course. So we're going to use HeatWave to do all these analytics. And I will show you example in a few slides also. And something very interesting, it's that HeatWave can do this analytics in real time. But we're going to see that after. So once you have an Oracle Cloud account, so and I will also send you in the future slides how to do that, right? Or to create, and you have some credits on OCI. You will have to create a VCN. So this is the network. Then you need to have a public and a private subnet and an internet gateway, security list, because security is very important. Then the compute instance where we're going to put the router, if you remember the small architecture I show you, and a database instance. So you need to deploy all that manually. So if you have that already, it's fine. If you don't know how to deploy that, or if you think it's quite complicated, you can use Oracle Resource Manager stacks. Stacks are Terraform modules, all embedded for you, that makes it very easy to deploy something in OCI. And this is what I want to show you right now. So I made a stack for you available in GitHub. So GitHub, Lefret, OCI, IoT, MDS. And when you go to GitHub, this is the page you see. And you can see there is a button there to deploy to Oracle Cloud. So you just need to click there and you reach this screen directly. It opens. If you have already an account in Oracle Cloud, and if you're already logged in, if not, it will ask if you're logged in, you get this, this screen. You need first to accept the terms of use. And when you accept it, you will see all these fields will be pre-filled automatically. So you can see that there is this Oracle PiDay on OCI with MDS. This is the stack information. Then you can give a name for this stack, or it will generate one for you. It gives you a description. So in this case, that the Oracle PiDay IOT to OCI with MySQL Database Service. And then you click Next. Next, you have some variables that you need to fill, of course, like what will be the user that has access to MySQL Database Service as administrator. So in my case, I put admin. Then you need to add a password. Then you need to give a name to that instance, because you may have multiple instances. So by default, it's already pre-filled. You have the name, it's MySQL Instance, and the server where the root router will be, it's called IOT server, right? Then you can say that on the IOT server, there is something here that you can click to deploy an Mqtt. So this is a broker, message broker, a server that we won't use right now, but I already create the Slack for you to use if you want to use a message broker and send messages, which is the better way to send message from an IoT devices to somewhere, right? But this is a message queue, and you can deploy it with the Slack. We won't deploy it right now. After that, here it's you can say, oh, I want HA for my MySQL database service or not. You can say, I want to deploy, or I want to deploy HeatWave cluster directly from now, which we won't do either right now. And then you need to have the shape for your compute instance and the shape for your MySQL database service. Here, you always recommend, because one, it's cheaper, and two, it allows you to evolve. It's to use a HeatWave ready shape. So in our case, we're going to use MySQL HeatWave VM standard E3. So meaning from this shape, I will be able to move to HeatWave later. If I want, I will be able to deploy a HeatWave cluster from this shape. If you are using another shape, you will have to take a backup, restore it on a HeatWave ready shape, and then deploy your HeatWave cluster. So as I know, because my goal is to show you HeatWave also, I will use the MySQL HeatWave shape here, right? So when done, you can see you have some details that are an overview of what will happen, and then you can say run, apply, and create. Then a stack job will be created, and you can see it will be in orange because it's in progress. And this will deploy all the resources that you need. So the VCN, the subnets, private and public, the security list, all that, the compute instance, and everything will be installed for you, the router, everything. So when it's done, it becomes green, as you can see here, and you have some logs, and you have all the information already deployed. That takes some time, of course. This is some minutes. This is why I don't do it completely live right now. You can see it took about 8 minutes to do this. So when all it's deployed, you have in the output of the job some information which are very important. For example, the public IP of the IoT server where the MySQL router is running. So here you have the public IP, as you can see. Then the instance of the MySQL Database Service. And you have also a private key that you can use to connect in SSH to this compute instance if you want, right? So that's done. If we go in the database systems overview, we can see that our MySQL instance, it's running, it's green, and we are happy. And if we go in the compute instance, we can see again that it has a public IP that we can use. So now everything is ready. So we have this MySQL database system deployed. So now we're gonna work on the data design. So schema, tables, collection, how are we going to store the data from this IoT device to MySQL in OCI? First thing, very important, if you remember, I said earlier that MySQL is a relational database, but not only. So with MySQL 8, you can mix relational tables and JSON documents. So SQL plus NoSQL equal the MySQL document store. It is very possible to mix all that together into MySQL, and of course in MySQL 8, and of course in OCI 2, so in MySQL Database Service. So this document store, it's built on the MySQL JSON data type, and of course on the MySQL server. So you don't need to install anything special. When you install MySQL server or when you deploy MySQL Database Service in OCI, it's already ready to be a document store too. So it provides you schema-less flexibility to store JSON documents. No SQL required, so you can create programs without SQL, because when we talk to developers, a lot don't really like SQL. They prefer to use CRUD operations and stuff, and you can do that with MySQL too. Of course, you don't need to define all the possible attributes, just the attributes that you need. And if you want to extend that later, if you add a sensor on the IoT device, it's possible too. Then it uses a new DevX API, so which is available on premise and also only in OCI Cloud. So if you want to use the X protocol, you have it by default in OCI, and other cloud providers don't have this, don't support the X protocol most of the time. So you can have all the column you want, and you can do search on it, and we're going to see all that together later when we do analytics, or we can retrieve that information, because this is what we're going to use today. Then the document, so this document that you store with in JSON can be up to 1 gigabyte. So not 16 megabytes, as some others, let's say, document store provide, but here it's up to 1 gigabyte. And like I said, you can do modern programming like CRUD operation and something and all that kind of stuff. And you can mix both. So you can mix the relational tables and the NoSQL JSON documents together. And it uses MySQL. So this is the design that we're going to use for the IoT device, for the Raspberry Pi with the sensor. So we will have a collection called devices. So collection means this is a JSON document that will have a name for the device, a short name for the device, the temperature, so the current temperature, and the humidity, and its public IP. We could add other stuff if we want, but this is what we will have in the collection. Then we will have 3 relational tables. One is the public IP history. So every time a device will change its IP, its public IP, we're going to store it in an historical data table. Humidity history. So every time we collect humidity from a device, we will put that data there. So we will be able to do analytics, collect whatever we want in a specific table. And the same for the temperature. So these 3 on the right are the relational tables, and the big one on the left, it's the collection. I put it big one, but in fact, if we check the size later, the history will be much bigger. So let me explain this. So all the real-time information. So if you have a dashboard and you want to show the real time of the device, for example, we're going to read the data from the collection, from all the JSON documents. We have all the latest data there. And if you want to give like an overview of historical data, we're going to use the history tables that we create, the relational tables, right? And this is what we're going to use later in HeatWave and I will show you that we can improve the performance. So now what we're going to do, we will connect to this MySQL instance, right? So from my machine, I use the public IP of the compute instance where the MySQL router is installed. And I use the port 6448 instead of 3306 or 33060 for MySQL classic protocol and X protocol. So 6448 will forward to the X protocol on the MDS instance. So as you can see, I'm connecting with my admin user, the public IP, and the port 6448. If I use 6446, I will reach the classic protocol. But here I want to use MySQL document store, so I will connect on the X protocol. So as you can see here, it provides me that information that I'm connected on the X protocol, right? Now, we're going to create our first collection and the schema. So the first thing we create a schema called PiDay, and we put that object in a name called DB, a variable called DB. If you don't know what you are watching on the screen right now, this is MySQL Shell. So MySQL Shell, it's the new MySQL client for MySQL. So it replaces the old just MySQL that you have in command line, and it provides you JavaScript mode, Python mode, or SQL mode, all the three. It provides you classic SQL, but also it allows you to do CRUD operations like in JavaScript and in Python. And finally, but we will not use it here, but it provides you a lot of tools when you want to do upgrades, and it provides you the possibility to use also the admin API from the shell that allows you to create different architecture like InnoDB cluster and so on. So now we have created that schema, and it's called the DB. Then we're going to create a collection called devices, and I will attribute that object to the variable called call, as you can see here, right? Let me see here. Then we're going to add one document. So I do code add, and this is a JSON document. So my first Raspberry Pi, this is the big name, a short name I will call Lefred PI, and for example, one of the attributes, temperature 0. Then if I do call find, I have it. So as you can see, I was able to create a collection to retrieve information from that collection very easily in JSON. All that from the MySQL shell. And this is all the information that you can see here. It's in OCI. Then what we do, we create also the relational table. So I go back here in SQL mode. So I just do \SQL. I use the schema PiDay, and then I create my temperature history table, my humidity history table, and my public IP history table, right? So this is what we do. The device ID, it's a varchar 32 that comes from the collection, and we have everything. Now, as I told you, we will have a lot of data. That's the plan. The plan is to retrieve data from many, many devices like this one and get a lot of information. So when we want to deal with a lot of amount of data, one of the biggest problem we have, other than retrieving the data and using the data, sometimes it's also archiving, deleting data with old records that we don't need anymore, right? So HeatWave has been designed to deal with that huge amount of data, but the MySQL server itself has maybe issue when you need to, for example, archive a lot of data, really a lot. So partitioning is a solution, because you will be able to say, oh, that partition from that year or that month, I don't need it. And you can delete that partition very quickly. So it is the thing to do. So do it right the first time, plan ahead, don't like here, right? And we're going to create this partition. So what we're going to do, we will now, remember, we have that information here. So we're going to create this partition using the date from the timestamp. And we're going to create several partitions for what was before 2022. And we go there until 2024. And then the max value. So we're going to create several partitions like that. And of course, you can create partition when it's running, no problem on that. You just manage your partition. But at least it's much easier to say, oh, when we are in 2024 and I say, oh, the January 2022, I don't need it anymore, you can remove that partition very easily, right? So now we are ready with the design of the table. So now what we need for our application, it's a dedicated user to connect from the device to MySQL. So it's a best practice that every application use their own user. Please don't do like I see a lot that people are using root or the admin and that's it. So we're going to create one user here to connect, same user on all devices, for example. But as I said, connecting all devices directly to MySQL, when we have a small amount, it's okay. But when we have a large amount of devices, then it's better to use a message broker like Mqtt that I've said earlier, and then I will show you after. So we're going to create that user. I call it PiDay. I will identify it by MySQL native password. Why this and not the new plugin? Is just because on small devices like this, depending on the version we have, maybe we won't be able to support the new encryption and new authentication plugin. So with native password, we are sure that even if we have an old version of Python, it will work. So we use then, we give a select, insert, update for that user on that database. That's it. So now we're going to start by collecting the data. So from the Raspberry Pi to MySQL itself. Like I said, I'm using Python. I'm not a big developer of Python and stuff, but I try my Python. I hope it's much better than my Java. So I did it in Python. And like I said, we need it's not Adafruit, but Adafruit DHT module to read from the sensor. So we import that information. Then we use it like this. And we read the data from the Adafruit DHT read-retry method. Very easy. So this is to read the data. We put that data, the humidity and the temperature, in two variables, and that's it. Then this is all for the sensor. 4 lines, nothing very complicated. The GPIO4, it's in which pin I connected the sensor. Then we need to connect to MySQL, of course. And like I said earlier, we have plenty of connectors that are supported and maintained by the MySQL team. Of course, Python, it's one of them. And so we're going to use MySQL connector Python. So to do that, I use MySQL X module. So I do import MySQL X. These are my connect arguments, right? So the public IP, the port, the user, and the password. And I use by session equal MySQL X get session and with all my connect arguments. And I'm connected to it. And that's it. So to connect to MySQL, we use MySQL connector Python. And to read from the module, from the DHT module, we use Adafruit. So now we have everything we need to create our script that will collect all that data. So this is the code. It's on GitHub also. So, but at least I wanted to show you here how it looks like. It's not that big or that important. So we import some modules. We give an ID to our Raspberry Pi in case we don't provide it as an argument, because the plan is to provide the ID of the device directly as an argument of this script. Then we read from the sensor, we use the sensor, we define it, then we define the connect arguments. And finally, this is what we use to connect. So we connect and we find also the external IP. Like I said, I want to store the public IP. So I use the URL request to get that information. Then I connect to MySQL. And here you can see I will do a schema session to get the PiDay. And then I put the temperature history. I define that variable temperature history. It's one table. This one is one table, this one is one table, and this one is the collection, and I call it call devices. So this is the initiation of all our variables that we need, and then we connect. And then it's a loop, because we want to collect that data all the time. So if there is no session, because for any reason the MySQL session was stopped, we connect again, and then we read the information from the sensor. And if there is some information that we were able to read from the sensor, so like the sensor is not broken, we will find the device. So we use the ID, from device, to get that information. And then we check, okay, if the new IP is the same of the old IP, we know it or not, so we check that, and then we can say, okay, if we don't find it, it means that this device was not already created in our collection, we're going to sleep. So nothing very important here. Now it's more fun because we're going to create an empty JSON document, and we're going to say, okay, we search for the humidity, and we print it as a nice string. We search for the temperature, and we make it a nice string too. And then here we do a patch JSON. You will see it's very easy. So we do patch JSON humidity equal humidity, patch JSON temperature equal temperature. So we just create a JSON document with that information. And after, what we do here, we do modify our device, so that are the document in the collection with the latest information. So this is why it has always real-time information in the device itself. And after that, we start adding the history information in the relational tables. We just insert every time a new document. That's it. So nothing there. And to start this script, what we do in etc systemd, this is what we do. We just have a service. We create a Linux service that run the Python script with the argument. It's the ID of the device, and that's it. So if we want to test our script, what we're going to do? So on the Raspberry Pi, I just do systemctl start PiDay metrics and the ID of my device. This is because I choose that to have the same script to be able to run multiple devices if I want. And when it does that, in the background, it will start collecting the data every second. And on MySQL, we can see, okay, device find, and you can see here, this is the ID of my device here, because it's the ID of the document, then the name that we enter earlier together. And here is the humidity that it gets from the sensor, the public IP that it gets from the Raspberry Pi, a short name that we enter earlier, the temperature that we get it also from the sensor. And every time we do that, we have a last update. So we know at what time was the last time we communicate with the device. And all that information, it's also in the history. So if we check the history, we can see that we have every second, we have information. It was here with the value. This is the humidity. So we have the humidity that was entered every time with the value. And we were able to do all this without any single line of SQL yet. All that is using MySQL X protocol with document store. So it's very, very easy to do. And every developer, even if I see that Carrie Nermo says it's a bit complex, yeah, this is code. And IoT, some code needs to be written, but it's, because I'm speaking right now, but if you check the source, you will see this is very short program, very easy to understand. It's Python. And so we just add records, insert records very easily. So the improvement to make something better, it's to use an Mqtt broker. This is what it's recommended. And remember, when we do the stack, it was possible to enable that directly, and it will install it for you. So instead of all the device connect to MySQL via the router, here they just send messages to a Mqtt broker, and then we have a MySQL writer that will consume that information. So we have a producer of messages and a consumer of messages. You can use one Mqtt directly on a compute instance. This is what you can do with the stack. Or if you have the possibility, you can use OCI streaming service to do that too. But it's more complex to set up maybe for stuff like this. but it's possible, and this can scale a lot, right? So this was about our device sending data to MySQL and how to do that. Then we let it run and it generates a lot of data. We go with MySQL on steroid, right? So what we're going to do now, we're going to analyze the collected data. So let's get some statistics of the metrics we collected so far, right? And I use a query to have all that information about what's the max temperature, the minimum temperature, the average temperature, the max humidity, min humidity, and the average humidity for a device. As you can see, I have 4 devices that were connected to MySQL for me. And this is the information. As you can see, max humidity, we have some strange number. It's because I made some issues when I created it, but doesn't matter. It's just to have that information here. So you can see, and what you can see here, which is what is very important here, is this number here. So I have only 4 devices that were running for 1 day, not even full day. And this took me 2 seconds to get that information. So it's 1, 2. For human, 2 seconds is nothing. For DBA, it's a life. This is long. So let's have a look at the query execution plan for this. And as you don't know, the query execution plan, it's returned by using the explain command in a keyword in MySQL. And you have also different format. And this is the format 3. So we can see what it does, the cost of the query, and everything it needs to do. So it do a table scan. This is the thing we try to avoid as much as possible when we are a DBA. And then group aggregate, index scan, then again here, a lookup, and again another table scan on a temporary table. So it's a very bad explain plan, but for the data we want to do, it needs to do that. It needs to read all the information to retrieve all this aggregate information, like the max, the minimum, and all that kind of stuff. So now let's have a look a bit more, right? Here, another query again, and you can see here, it took me 1.2 seconds, right? So these 2 queries are the 2 examples we're going to use together later. So we have information again for every day. So every day here, every device per day provides what's the total information they receive. So the total metrics they got from the device, and then maximum, minimum, average of all the sensor values, right? And it took 1.2 seconds. Again, we can see here the query execution plan using temporary table to get that and doing table scans to get that information. So this was fast, not that slow, but for the small amount of information, this was not really fast, right? And we expect to have much more data than this. So let's boot this using HeatWave. So we have 2 options to enable HeatWave, or we edit the stack we created earlier, or we use the MySQL Database Services console. So I will show you how to do that. So with the stack that we create earlier, so we had that job that was running and it's active, right? We can do edit, and we say deploy HeatWave, and save the changes, and that's it. At the end, we have HeatWave enabled. If you want to do it with the console without using the Slack, when you have your database, the MySQL Database Service, you can say, oh, I want, you click on the 3 dots, and you can say add HeatWave cluster, or on the details itself, you can say enable HeatWave cluster, right? Then you estimate the count. It will estimate for you. So you can say by default it takes 2. This is the minimum, 2 nodes in the HeatWave cluster. But you can say, oh, I want to generate estimate with the data I have. But as you can see, we had very few data so far. So it says, okay, it's 2 because this is the minimum. And you have also a load command that we need to remember. So we copy paste it for later. And we say apply and we let it go. When HeatWave is ready, we can see HeatWave cluster, it's enabled. And in MySQL itself, we can see that the cluster status is on and online. So this is what we need. We have cluster running, and this is exactly what we need, right? Yeah, for the question, I will answer after, please, because I'm alone, but I will answer you live the question. I saw Sabino submitted a question. So now we're going to use the load comment that was printed when we did the estimation of the count, and we will load all data to HeatWave. So all the data we need, we will load it to the cluster. So it's just a call like this, and that's it, and it loads it directly here. So it gives you a lot of information and a summary, and the load took 1 second 84, so the total was less than 2 seconds. So now that we have loaded that data, what do we need to do? So we just do a select, the same select as earlier. So remember, I made 2 examples, and you can see now the speed. So we went from 2 seconds, a bit more, to 0.1 second, 20 times faster, just because we enabled HeatWave and we loaded.
He will be back soon. Give him another minute or 2. If you haven't joined our public workspace, I'll send you the link for you to join, so you can also ask questions, see what's coming up, what other events are coming up. Here, let me put it in the chat. If you have any questions, please ask in the chat. And we have, let me see, 5 more events coming up for today. Yes, Carrie, you can ask the question in the chat and they can answer as well. And Sabino, I saw your question. He should be back soon. If not, you can also ask the question in the chat. I'm sure that there are a lot of people will be able to answer that for you as well.
Sorry, like I said, it happens that this crash happened. So let me share again the screen. I'm very sorry about this. So let's go back where we were. We did that. So we were here. You can see that the query is it's faster, so it's good. And so this is what we were expecting, right? So next to that, we use again the second example, but now with 7 days of data, so much more data. And you can see that without HeatWave, this this query took 5 minutes. So it's a lot, right? And if we do it with HeatWave, it takes less than 1 second. So this time it's 421 times faster. More data you have, more you will see the difference when you are using HeatWave, right? So, and this is with 5 GB to parse, and we need to parse everything, right? So let's double that data to have an overview. So for example, I will double the data. So now I have 11 gigabytes of data collected. So without HeatWave, it takes 10 minutes. With HeatWave, it takes 1.6 seconds to get the information. You can say, oh yeah, but the rows are different. Of course, because HeatWave, it gives a real-time analytics, meaning that in the meanwhile, the devices were still collecting data, right? So this is why that for your IoT projects, MySQL and HeatWave, it's very good. If you have a very small amount of devices and very small amount of data, MySQL Database Service is good enough. If you have a lot of data and you plan to parse a huge amount of data, MySQL HeatWave is made for you, because then, as you can see, it's much faster, right? So when you need to deal with a large amount of data for analytics, right? This is the traditional architecture you have so far. So you have an OLTP application that sends data to MySQL. And then you have an OLAP application that needs to get the data from an OLAP database. And in between, to provide that information to the OLAP database, we are using an ETL service. And that ETL service, it's run regularly, maybe, but it doesn't, this is not real time. So the data, it's not real time when you do analytics. When you are using MySQL HeatWave, no more ETL service is required, because the OLTP application, the OLAP application use just MySQL Database Service. So it's exactly the same. You don't need to change anything in your application, same entry point. And if it has OLTP stuff, it goes directly to InnoDB, which is our OLTP engine. And if it's needed, the query, if the optimizer can see that the query will be much faster with HeatWave, automatically goes to HeatWave, and you don't need to change anything, and you get the result much faster. So it's a one single database to do OLTP analytics application, right? And with the performance we just saw together. So MySQL HeatWave, it's one solution for everything. So you don't need to run analytics on a different engine and to externalize that data somewhere and somehow. So no need to all that. All it's automated. You send your data to MySQL, you query MySQL for your analytics, and it will work, right? So if you want to see if you are using HeatWave, you have a status called rapid query offload count that, for example, for me, in my case, 17 of my queries were offloaded to HeatWave, right? And when you do when you run again the query execution plan using explain, you will have using secondary engine rapid, meaning that you are using HeatWave. HeatWave has also machine learning capabilities, right? And it has several autopilot processes that are available directly when you install HeatWave. It's the autopilot encoding and the autopilot placement. So you can, once you have queries and you do queries and you are using HeatWave, HeatWave will learn on that. And after a while, when you get enough information, you can run this autopilot encoding advisor and this autopilot placement advisor, and it will provide you information and queries to change if needed, to change the encoding or to change the placement, how in the cluster they need to be, to make it much faster. So all that is automated by machine learning, right? So this is how we were able to, from IoT, send data to HeatWave and to process it. And now let's have a look what we can do with analytics, because we are using HeatWave, which provide us this real-time analytics, right? So what is Oracle Cloud Analytics? I'm not an expert on the Analytics Cloud platform, but I tried it and it was very easy for me to do it. So it's not that complicated. It provides you a lot of information like visualization, preparation, and all that. And I wanted to show you example with the data we have now done today, right? So we are able to connect. So we can connect to multiple stuff. We then model, create our model, to prepare, explore, experience, collaborate. But we're going to show this in details. So for connectivity with Oracle Analytics Cloud, you can connect to many sources, and of course, including MySQL natively. So this is what we're going to use because our data, it's on MySQL HeatWave, right? Or you can also do a drag and drop with the file description of where the data is and how to get it, right? After that, so we create our connection, we use MySQL, and this is the data we have created earlier. So this is, we put the public IP of our router if we are not on the same VCN, or if we are on the same VCN, we can use the private IP of MySQL Database Service, and we can define the port if you are using the router or not. The database is PiDay, then user and password. And this is the connection. After that, we can do the data modeling, and OAC supports multi-table connection or very custom query interface. So you can remember we had this relational tables that historically that we created. We can just click and say use them, or we can create our own query to get information like the one we did earlier, to get all this average summary and stuff with the device name that comes from a collection, for example. All that it's possible, right? So when we have done that, we can create our own data set and use the PiDay connection to use it, right? And this is how it looks like when you create it for the first time. And you can say, I want to add the humidity history in my data set. Then I want to add the temperature history in the data set. And you can say, I want to join that data in together. And in our case, we're going to join it by using the device ID that we created in the tables, right? So this is how we do it. And that's it. Then this is the information we get when we have joined these two tables together. We have the ID, the timestamp, device ID value, and we have already some kind of graph that we can have some information, right? And something very important when you are using HeatWave, it's that here you can say, I want the data to be live, because HeatWave, it's an analytic engine, but live data. Every time a device sends data to MySQL, that the data it's directly sent also to HeatWave at the same time. If data is modified, it's modified to HeatWave. Like I said earlier, there is no process to sync them and stuff like that. It's all real time. So it works in the Oracle Analytics. You can benefit from that real time. Now, like I said earlier, remember we were using a JSON document to put all our devices, and the name, for example, it's there. So if you want to retrieve that information and to use it also and to join all this table, what you can do with MySQL, it's to create fake columns, so generated columns that you can even index if you want. And here we're going to create the short name column. So it's a, for example, here, the short name, it's a new column that it's a varchar 20, and it goes in the document itself, and it is the short name attribute. So if I do a select now, I have the device ID, so in SQL, and the short name out of the JSON. They are still in the JSON. They are not materialized. They go there to retrieve that information. But now I can use that information to join everything I want, for example. And this is how I create a list of devices. Oh, not again. So the list of devices here, and now I can add it to join that data to my analytics, and I can create many queries like we did earlier. So this is the queries we create earlier, and we said I want it live, and it goes directly to use them. So thanks to that, we can create a very specific queries for us for all our stuff. Then we can also have that data preparation. Right? So we can generate ourselves what we want, so lowercase, modify the data we retrieve, or use machine learning. Machine learning in Oracle Analytics Cloud provides us also it gives you some information to say, oh, you can use, for example, I saw you have a date type. You can say, oh, I want to retrieve the day of the week, the day of the month, and stuff like that. It's all, you don't need to do anything. It does it for you with the machine learning processing that happens. And you have also natural language processing to natural language generation. It's also possible with Oracle Analytics Cloud. And why do we do all this? It's to create this very nice visualization that we can have. So we can create summary, drill down, and so on. And that provides you also the possibility as a developer of creating these analytics dashboards to have the performance. And when you are using HeatWave, you can see that it's very, very fast because now it's processing a lot of data. We are now processing millions of rows. So from that, what we can do, we can create this very nice statistics models also, and we can generate information about how it will, some expectation of what will happen with our devices. But this is more information about how it works, right? And what to do. Other than that, this Oracle Analytics Cloud provides you export options. So all this nice dashboard we did, we can create PowerPoints out of it. We can create PDFs and images, whatever we want. And we can even share them on a social network. So with Oracle Analytics Cloud, with HeatWave and MySQL, what we can do, we can create this real-time dashboard, and from all the data we collect from this Internet of Things devices, in our case, the Raspberry Pi, and we can generate stuff like this, where we can see what's going on, what will be the trend, and so on, and make alarms and whatever we want out of it. So sorry for the technical issue we had, but as a summary in the journey we had together from IoT device. So from this small device that was sending just temperature and humidity information, we were able to create a real-time dashboard. Oh, this is me, sorry, I typed wrong. So we started from this single Raspberry Pi. We collected a lot of data, really a lot data, and we were able to run queries super fast, and we're able to run to make this ready for analytics in real time when we enabled HeatWave and we get rid of this ETL service, and we were able to see the limitless, but I'm not an expert on that, but there are plenty of nice sessions about Oracle Analytics Cloud if you're interested in it. And all this thanks to MySQL HeatWave, right? So now this is just some slides you have maybe seen already if you have followed the PiDay all the day, but it provided how to get a free trial for OCI, right? You will have this in these slides. The slides are available or will be available. They're also on my slide share, and how you can get some free credits to. You need to fill everything, and when it's ready, you are able to use a OCI tenancy. So the free trial, if you're interested, just scan this or go to bit.ly PiDay free trial, and you will get information. You can share, if you like our event, please share it on social media. You can join our Slack channels. So we have a ODevRel Slack and a MySQL Slack too. So please join. And run workload your way on OCI, so there will be Oracle Live soon also. And please, there is like a quiz that you can join to test your PI knowledge, because P is the limit. So please join. You will have some fun playing the quiz with us. And if you have any question, I will have a look right now if there are questions, and I see there were some. So is it only available on OCI? Can we run it locally? No, so HeatWave is currently only available in OCI, right? And you cannot run it locally. So because this is very, to make this very powerful improvement, this is very linked to the hardware and the software and stuff like that you have. So currently it's only on OCI. Now, yeah, there is this is really something special for us, but let's see how it goes, right? So yes, the GitHub links here is the, so Brian, I answer you. Would it be easy to connect this data to some sort of notification monitoring service? Yes, now the data, you have it. So for example, myself, when I play with that on OCI, so with the analytics, you can make some option, but if you prefer just to have some other monitoring or notification, for my personal usage, I use Sensu, for example, that can read data from MySQL and do whatever you want. But every monitoring systems that can read MySQL can get that information. So you just need to install that monitoring system on the compute instance in OCI, for example, if you want to use OCI, which I recommend you. But it's possible to do it without any issue. It's just MySQL, and you just need to read the data from it. So if you have other questions, please don't hesitate. I'm looking at the question chat. So the quiz URL, go back to it. So this is the quiz URL. Let me type it here. So don't hesitate to join my colleagues' other sessions to get some information about the quiz. So if you are more interested about Oracle Analytics, you can have here a full live lab to use MySQL Database Service with HeatWave and Oracle Analytics Cloud. So at the end, it was a bit fast, sorry, because it was very quick due to the hardware issue I had, so I apologize for that. But you know how to reach me. So I'm mostly just go on Twitter, ping Lefred or send me something on Lefred, at Lefred, and I will answer you. And so thank you for watching. I think we are just on time, just a bit late. So if you don't have any questions, if not, I'm still here, so you can ask me some questions. I think there were some questions before my system crashed, but they have disappeared, so I don't see them anymore. So if I didn't reply to your question, just type it again because I don't see it anymore. I see there's one. So I think this session will be recorded. The recording of the session will be shared, but yeah, I hope they will cut when there are some technical issues. But the slides are already available. That's for sure. And so, if that answered your question. Thank you, Debbie. So I hope you enjoyed the session and that you are interested in using MySQL and with HeatWave in OCI. And I really, really recommend you to test yourself with your own data. You will be very surprised about how fast it is. The code on the IoT device on the Raspberry Pi, it's on this GitHub. And this is the stack to deploy MySQL database instance and the router on the compute instance on OCI. So thank you. Bye-bye.